back to Let's Learn Together. I am George Yusuf. So in this video tutorial, what I have in front of me is an array of 10 numbers. These are all byte-sized numbers, meaning nothing is bigger than 255 decimal. Now what I want to do is sort these numbers in ascending order. So we'll start first with simple, only two numbers to sort. So I'm going to comment the rest of the numbers out. What we want to do is sort these two numbers. So in other words, 12 must move to the left, 52 need to move to the right. So how are we going to do the sorting is, obviously, we have to load them in registers and compare the numbers. So the first thing we want to do is set up a pointer. I'm going to say load effective address into SI register of our array, right? And now we can load numbers into AX register. And since these are byte-sized numbers, they're going to fit perfectly in AL and AH register. So we can start loading pairs. I'm going to say move into AX what SI is pointing to. Bear in mind, some assemblers will not allow you to do this because SI is pointing to byte size data, which is dB, as you can see here, and AX is 16-bit register. So you might have to do something like this. Word PTR SI. This will load 2 bytes at a time, a pair. So this will load 52 and 12 into AX. 52 will go into AL, 12 will go into AH. A shorter version of this is W dot. Let's check this out. I'm going to emulate in a single step. I'll set up the pointer first and then load SI into AX. Let me show you the variable. This will load 52 first in AL. The second number, number 12, will go into AH. Single step. As you can see, 12 in AH and 52, which is 34 hexadecimal in AL. So now we can compare these. I'm going to say compare AL with AH. Let me keep this open so we can see the registers. Now, anytime you do compare, you need to ask yourself about destination. Is destination bigger or is destination smaller or is it equal, whatever the criteria? I'm going to say is destination, which is AH, smaller than AL. If it is, jump. So I'll say jump if below. That's the question. Jump if destination is below to, let's create a label, call it swap. And I'll put this label down here, swap. What swap will do if AH is smaller, then swap the two registers. So I'm going to do exchange AH with AL. Once we exchange these numbers, we're going to send them back to memory, location where they came from. So all I have to do is reverse this instruction. I'll do move into Word SI AX. We just reversed this previous instruction over here. So let's emulate and see how this works out. I'll set up the pointer, load first pair of numbers in AX, compare, jump if below the swap. The jumps will exchange these two values in AL and AH, and then we can send them back to memory. Here it is. You'll notice 12 will move to the left and 52 will move to the right after the last instruction, and it did. So this is how you sort two numbers. What if you have three numbers? I'm going to comment the remaining of the numbers. I have 3 numbers here to sort. Since sorting 2 numbers requires one comparison that we did over here, having 3 numbers, we're going to need to do 2 comparisons. First with second, and then second with third. So we're going to put a counter on CX. They move into CX register 2 to do 2 comparisons. Right? So after the first comparison, it ends up over here. After it's done, I'm going to say loop, call its label again. I'll do the same thing over here in case it does not jump. I'll say loop, do again, and I'll put again where? Right here where it's going to load numbers in AX register. Yeah. Okay. This will go back here, load the new set of numbers, load new set of numbers in AX register and do it all over again. Compare it, jump accordingly, whether it's small or large. Let's emulate this and see how this works out. I'm going to open the variable to see it. Put 2 in CX, counter, set up pointer in SI register, then load the first 2 numbers in AX, sorry, compare, jump, exchange the 2 values, send them back to the memory. Notice 12 moved to the left, 52 is on the right, and we'll go back to loop, back to this point where we're going to load the new set of numbers in AX register, which will be 52 and 44. Because we increment SI to 103. It's right here. 103 is number 52. It's going to load these 2 numbers. 52 goes into AL, 44 goes into AH. Move back, load the new set of numbers. Here we go, 34 in AH. We increment, oh, we didn't increment SI, I'm sorry. Let me increment SI after the jump. Increment SI, and we'll do the same thing here before the loop. Increment SI. Okay. And let's run it again, single step. So we swap the first 2 numbers. 12 is moved to the left. We'll increment SI to point to the next byte in our array, which will be the second byte, 52. Now loading 52 and 44, loop back into AX register. Here we go, 2C and 34. Now we can do another comparison. Jump if swap, which is, it will jump. Sorry, jump if smaller, below. Now exchange the values, move them back to memory. Notice 44 moved to the left. Increment SI again. Get ready for the next pair of numbers to be loaded into AX and loop back. But loop will decrement CX first, which is 1 at this time. It'll decrement it to 0, and then it'll check if it's 0, it breaks out of the loop. In this case, there's no other instruction after it, so it goes to the last instruction in our program, which is ending the program. There we go. Program ends after 2 comparisons. So instead of doing 2 numbers or 3 numbers now, let's do all 10 numbers all at one time. So since we have 10 numbers, we're going to do 10 minus 1, 9 comparisons. So all I have to do is change the counter to 9. Oops, that's 9. And I'll run it again, this time at a slower speed. There's the counter in CX. Once it reaches 0, it breaks out of the loop and runs to the end of the program. Done. So what happens is the biggest number, which is 164, moves all the way to the far right. Oh, we still have some sorting to do because 4 is still somewhere in the middle and 8 is at the end almost. So we'll have to come back and do another pass to keep moving the smallest numbers to the left. So how we can do that is, since we're using CX counter for this loop, the comparisons loop, we're going to set up another counter for passes loop. Count how many passes we're going to do. And we'll do the DX register. We'll set up DX register as our counter. So I'm going to delete this because we don't need it anymore. I'll say move into DX register 10 for 10 numbers that we have in our array. The first thing we can do is decrement DX to do 9 comparisons. We'll decrement it to 9. And we'll set up a check over here. We'll say jump at 0. So if DX reaches 0, that means we've done 9 passes already. So we'll jump to the end. Otherwise, we'll copy it into CX, move into CX DX to set up counter for our loop, for these loops. And we'll continue. Let's emulate now, and I'll run it slower until our CX register, which will be, let's see, 10 and DX. Here we go, A and DX. We'll decrement it to 9, copy it to CX. Now CX counter for comparison set up to 9. I'm going to run it until it hits 1 or closer to 0. 7, 6, 5, 2, 1. Okay. Single step, exchange, send it back to memory, increment as I. This is going to decrement CX. Now CX is at 1. Check if it's 0 or not. So if it's 0, it breaks out of the loop. It does, and it ends the program. Now what we have to do is, instead of breaking out of the loop and going to the end, I'll say jump to, we'll create a label where we want to start decrementing DX right here. We'll call it function 1. So we'll jump to F1, whether it lands over here or here. I'm going to say jump to F1. Either way, it'll jump back to F1 to decrement DX, check it if it's 0, and then copy it into CX for comparisons loop. So this is passes loop counter, and this one is comparisons counter. Okay, let's emulate and run it. I'm going to reach 1 stop. Okay, so I'll exchange this as the last one, put the variable. In our loop counter, we're almost at 0. Command is I, so it broke out of this loop because counter is 0, and we're going to send it back to F1, which will decrement DX. DX was 9 to begin with. We'll decrement it to 8. We'll check it if it reaches 0 or not. Copy it into CX to set up next number of comparisons that we're going to do, which is 8. Since we have 164 is the biggest number to move to the far right, we don't need to compare this one anymore. 164, so we have 9 numbers left. Since we have 9 minus 1 is 8, we're going to do 8 comparisons. And 8 comparisons set in CX register. And we'll continue. 5, 4, 3, 2, 1, 0. I ever did it. Okay, anyway. Same thing here. It's going to break out of the loop. Just run it all the way to the end. because all the numbers are moving. 4, 8, 12, and they are sorted in ascending order. Let's run it again, this time in full speed. Takes about 2-3 seconds. Okay, all the numbers are sorted. All we have to do is probably print them if we want out to the screen, and that will require another program to do so. But this was a short program that sorts 1 byte size numbers, and this could be any number. Whatever number here, if I was to add any other numbers over here, instead of 10, I'll make them 12 or 13 or 15 or 20 numbers or 100 numbers. All I have to do is change this number only in the X register. If I have 15 total, 15 numbers here, I'll change this to 15 right here. This program will still work as expected. I hope you enjoyed this program. Please hit the like button. In a future video, we'll do another sorting program that will sort byte size and word size mixed numbers together. Hopefully I'll have the time to do it in another video and post it. Well, thank you very much for watching. I hope you have a good day, and bye-bye now.